I hope you got to meditate on that. Or this, I should say. Now, let's talk about computer languages for a moment. Every computer language has three components. They are sequence, decision, and repetition. If a language has these three components, then it is equivalent to every other computer language. It is amazing that anything that can be done using a computer can be done just using these three things. Most of learning to code deals with becoming comfortable using repetition and decision. You may have heard of the if statement and loops. That's what those are. But right now I'd like to talk about sequence, which doesn't get any attention as we tend to take it for granted. Sequence means that there is an order to the code. This means that lines of code are read by the interpreter, line by line, from top to bottom and left to right. There are some details to this order that vary from language to language, but the point is that there must be an order, otherwise chaos. In Python, the code is read much the way we read a book. We go from left to right and top to bottom. So we cannot expect the reader to know the name of a character that we will only introduce later on in the story. Same thing here. We would have to add a function or variable to the namespace before we can use it. Moreover, there is also an order to reading parentheses, just like we have in math class. We saw an example of this when we used print_dir built-ins. We have parentheses to contain the parameters and we know we have to print something. So we look inside the parentheses to figure out what to print and find another function, in this case dir, which has another set of parentheses. We look inside of that and finally find a value, that is built-ins. We use that value to calculate dir of built-ins, and once we have that value, then we can print it. I think of this as set of nested Russian dolls where we keep opening them until we get to the last one, only to close them back up again. This is a common pattern in programming and in math as well. The main takeaway here is that we need to create things before we use them, and that parentheses work very similarly to how they work in math class. We go in until we find a value to do operations with, and then we backtrack to the outside. So how do we add something to the namespace? First, we figure out what the thing is that we want to name. Then we come up with a good, clear name for that thing. The name cannot have any spaces in it. Finally, we use the equal sign. We already talked about the print function. Let's give it another name, or an alias. An alias is just a nickname essentially. Let's give the function print another name. Let's make it p. Why would we want to do this? For one, it is easier to type p than it is to type print. Okay, so p equals print. Now the function that prints has two names, print and p. Let's test and see that we can use either in the same way. Print 5 and p 5. We also do math inside the parenthesis p, 2 plus 4, and see the result. Each time we run a code cell, any names created are added to the namespace and stay there until we restart the runtime if need be. Because cells in Colab can be run in any order, that can make the idea of sequence a little bit more confusing. But for now, let's just say that if you choose runtime and run all, that the cells will run from top to bottom in the order that they are in the notebook. Colab makes it easy for us to switch the order of cells using the arrows. This is a nice feature of Colab and makes you more productive as you don't need to run all cells every time you want to run some code. You can also add cells to any part of the workbook as you need to test things. Let's create some names for the height and the width of a typical screensaver. The best size for a background image is 1920 by 1080. We will be creating some fun screensavers later, and you can give them to your friends as gifts. Remember, we will be making AI art, so the sky is the limit. Okay, so let's make width equal to 1920 and height equal to 1080. Now let's print these. We can see the results make sense. It is not common to use p for print. You can if you want in order to type less. It is a common practice to use aliases for certain functions, but print is not one of them. I will just use print from now on.